Ooh. Oh, hold up. Let me see. It's not Deltarune. Oh shit. Alright. Just I'm gonna switch. Edit my thing real quick. Guess everyone's hopping back on Deltarune because of chapter 5. Alright. The update. Yeah.
Or a 2 because of that 1/2. You see the 2? What else?
Watch.
Are you ready to try some more advanced things with derivatives?
This is 2.3. Techniques of differentiation. Say calc 2.2. 2.2 slash 3.1 through 3.3. Alright. Damn, how the hell is my freaking charge this? Alright, it's charging. Alright, this is calc 2.3. Yeah. Focus. Calc 2.3. 3.1 to 3.3. Oh my god, I'm gonna go insane, guys. Fuck.
See how we can really use this stuff. You ready?
Yeah.
Answer's usually yes because we're going to do it anyway, so may as well be happy about it. 2.3. Today you're going to learn some rules. You're going to learn about the product rule and the quotient rule. Here's the scenario. Let's suppose that we start with 2 functions. I'm going to give you some very basic functions. F of x equals x squared. G of x equals x cubed. Here's what I want. want to know. Is it possible to take the derivative of one function times another function? Notice how this is f of x.
Alright, hold up. So, got an example. F of x of x cubed. D over dx.
X and this is g of x, right? The question is this. The question is this equal to this? I need more room. I want you to really write that down and contemplate it.
But
Is that true?
is d over dx f of x times g of x equal to dx f of x times d over dx g of x. I'd say it is. Ugh. Put this down. Shit off screen, bro. Alright.
Question is, can I do it? Can I break up derivatives by multiplication? Can I break up derivatives by multiplication? Can I say, oh, the derivative of f of x times g of x is the same as the derivative of f of x times the derivative of g of x? Can I do that? I don't know. We have no idea. I mean, I'm just asking you right now. But I can tell you this. If we can find one example where it's not true, then this whole scenario falls apart. So what we're going to look at is, let's look at this example and see if it's true for this. Now, I'll tell you right away that you could get x to the fifth right there, couldn't you? So we know for sure that this is true. This is the same as d dx of x to the fifth. What's the derivative of x to the fifth, ladies and gentlemen? So we know for sure that this is supposed to end with 5x to the fourth. Do you believe me? Yes, no?
Run the back to that. Okay.
What's the derivative of x to the fifth, ladies and gentlemen? Sure that this is true. This is the same as d dx of x to the fifth. What's the derivative of x to the fifth, ladies and gentlemen? So we know for sure that this is supposed to end with 5x to the fourth. Do you believe me? Yes, no? Okay. Okay,
Oh wait, I get it.
let's try this way. Let's try to do it. The derivative of the first times the derivative of the second. What's the derivative of x squared, our first? What's the derivative of our second? Is it the same? We get 6x cubed. Okay, we got two different answers. Which one is right? 5x to the fourth or 6x to the third? Which one's right? You should know. You should know right now which one is right. Which one is right? This one? This one. Which one's right? Is this for sure equal to x to the fifth? Every time. Every time. Do you know how to take the derivative of x to the fifth? Every time. We know for sure that this way was right. What I'm trying to say is, do you end with the same thing? I know for sure, guys, for sure, this is the right way. It gives me a correct answer. The correct answer is 5x to the fourth. That's the correct answer. Is this the correct answer then? No. So does this way work? So can I separate derivatives by multiplication? No. Is this true? No. No bueno. No, you can't do that one. That's not true. You can't separate derivatives by multiplication. So what are we supposed to do when we get these functions that are multiplied together? We either have to distribute them, or we have to find a better way, and that way is called the product rule, which is the name of our section here. We're going to look right now at how we actually do the product rule. So, product rule. Product rule says, well, if this doesn't work, what is the correct way? What do you do if you have one function times another function? You're trying to find the derivative of those things. Well, here's what you do. This is our rule. If you want the proof of this, come and see me. I'll give it to you. It's a little bit too long for our class. I usually will prove the things, but I'm not going to prove the quotient rule or the product rule for you. You want to see, just come and see me, okay? So product rule says, here's how we're going to go about taking the derivative of a product. We're going to take the derivative of the first one, the first function, times the derivative of the second function. I'm sorry, the derivative of the first one times the second function, plus the first function times the derivative of the second function. I'll write that out in symbols so you see it. You take the derivative
Way too much derivatives, bro.
of the first function times the second one. You leave the second one alone.
F prime
You add
x
to it
times g x
the first function
plus
left alone
of x.
times the derivative of the second. You've still taken the derivative of each one, but it's different than this. You have that addition in there, that product. I like to think product plus. P goes with P, product plus. So we're going to have that. You're going to see in the quotient rule that we're going to have a minus sign in between there. So product plus. Associate the product with a plus. By the way, would it work for over here? Let's check real quick just to verify, okay? So d dx of x squared times x cubed. Again, we're supposed to end with 5x to the fourth, right? That's what we're supposed to end with. If we do this, here's what it says. Watch what the product rule says to do. It says you take the derivative of your first function, that would be x squared.
Okay.
You find the derivative of your first function times the second function. That's how to write that out. It says you find the derivative of your first function times your second. Are you okay with the notation? Derivative of your first function times your second function. Then you have a plus sign. Then you write your first function times the derivative of your second function. In English it says derivative of the first times the second plus the first times the derivative of the second. Let's see if it works. What's the derivative of x squared? So this becomes 2x. Oh, ladies and gentlemen, do I need to take the derivative of x cubed in this case right here? You follow the dx. That's why I like the d.
just writing shit down and not thinking. So take derivative of the first one. Okay. Plus times regular plus regular times derivative of the second.
dx. It says this is what you're taking the derivative of. That's why we're going to write it like that in this class. Go, oh, this says take the derivative of this one, but don't take the derivative of this one. You're only taking the derivative of whatever's inside your brackets there. Do you see it? That's why we use that. It says, oh yeah, okay, derivative of x squared, that's 2x, times x cubed, plus, do I take the derivative of this x squared? How about this x cubed? Yes, that's why I said d dx. It says take the derivative of that. That's 3x squared. If we make this a little prettier, we have 2x to the fourth plus 3x to the fourth.
What?
That gives us, are we right?
Just combine all them.
Yeah, that works in that case. That's not a proof. That says it works for that example. You have to be able to prove it works for every example senior for that.
On the back turbo. How do you combine those? Oh, he multiplied. 2x4 plus 3x4. Yes. Equal 5x4. W teacher.
That you want to.
Or we can just trust it works for everyone.
You can trust it. Yeah, you can trust it if you want. I would. I mean, it does. So save me some time. But
Oh wait.
so in
I don't
English, the
know.
derivative of the first times the second plus the first times the derivative of the second. If you want to write that down, you can write that down if you like it at your leisure, or just watch the video again and hear me say it like 40 times. Just press rewind, okay? Derivative of the first times
Yo,
the
this
second
guy's
plus the
goated,
first
bro.
times the derivative of the second.
W teacher.
How many people feel okay with that so far? Now, we're going to do one example on how to actually do this. I'll show you why it can be useful a little bit later on. How it really, really does help us out a ton, and why we need it. For right now, you're going to be wondering, well, why can't we just distribute all the time? For right now, we will be able to distribute all the time and get the same exact answer. I'll prove it to you right now. I'll show you. However, later on, you won't be able to do that. And so the product rule will become very, very important for us later. For right now, it's going to seem like, well, wait, hang on. Let me show you an example of this. Hey, look at my function. Do I have a product? Do I have one function times another function? Sure, absolutely I do. I've got this function in parentheses times this other function.
Hold up.
But do you see that I could distribute this? Do you see it? If I FOILed this all out, I could do the
Nice.
derivative that way. I could do it for sure. I could do that. And so you might be wondering, why do we need this at all if I can always distribute? And the answer is, well,
Shoot, I'm getting distracted, bro.
you can't. You can't. Or you probably don't want to. For instance, what if I gave you, now we're not there yet, I'm jumping ahead to give you a precursor to what we're going to be doing later. But here's why we need the product rule, okay? You with me on this? We're not going to do it now. I haven't showed you this yet. But what if this was to the fourth? Okay, do you want to distribute that 4 times?
What's he doing now? Fuck. Y x squared minus 1. Can I show you my work on Discord? Hold up. Yeah. Interesting side quest. Alright, hold up. Graphic world. Let's see. Alright. Let me
times and then distribute that one.
Not really.
Heck no. No, that's ridiculous. Okay, that'd be crazy. That'd take up more time than limits would do, alright? No, we don't want to do that. We want to find ways around that. The product rule is the way around that. Do you understand? That's the idea.
Alright.
So it'd be good practice to start using the product rule now instead of.
Yes, absolutely. It's gonna on your homework. It's gonna ask you to do both.
Yo. Tough. I'd love to know. Let me. I don't know if I can afford anything yet, but let me first call this person graphic designer.
Do this two ways. And I'm going to show you next time how to do this two ways. I'll leave you with one. Don't pack up yet. I'll leave you with one.
Price. Bro. Yeah, I'm flat broke, bro. How do I tell you? Fuck. Genuinely broke.
One more thing, but it says distribute this. Find the derivative. Then use the product rule, distribute it, and then you're going to find out that you have the same exact thing, okay? So you're verifying that this product rule does work.
Damn, I guess, bro. Fuck me, I guess, bro. Alright.
This idea was about as well. One last question. So a lot of people always ask me, so I'm answering right now in the last couple minutes. Well, hey Leonard, isn't this
Alright, let me tap in.
a product?
That ruined my math focus, bro. Gotta lock in. Gotta
3x
lock in.
squared, isn't that a product? Well, of course it is. It's 3 times x squared. Yes. Why don't we use the product rule for this? If it's a product,
What's he talking
why don't we use
about?
the product rule? Wouldn't it come out different? And the answer is, we kind of do use the product rule, but we cheat a little. Well, we don't cheat. We just don't show a part of it. Here's why. If you consider this to be a product, check this out. You'd have the derivative. This would be your first, and that would be your second, true? You'd have the derivative of your first times your second, plus your first times your derivative of your second. All right, very good.
Okay.
What's the derivative of 3?
0.
0 times x squared, that's going to happen every time because that's a constant. So if you consider that to be a product rule, the constant is always going to go to 0. So we really don't show that step, do we? We just show, oh, look at, hey, the 3's outside. That's why we can pull the 3 outside of our derivative. That's a constant. We can do that. It's product rule. Says, here's positive plus 3 times the derivative. That's 2x. That's 6x. That's why we can do that. Okay, so to answer any questions you might have in your head, why don't we have to use product rule? You really are. You just have to do it, but ultimately, when we're working on the exponent here or here, we're going to need it, because you certainly don't want to distribute that out 30 times if that's your exponent. That would be crazy. So, how do we do this? 2 ways. Well, way number 1 is, what if we don't even consider it to be a product at the very end? What if we distribute those parentheses and make it so we just have a basic polynomial in this case? Well, if we do that, we'll get 3x to the 6th plus 2x to the 3rd minus 3x to the 4th minus 2x. Are you okay with that so far? Check for any like terms. Do I have any like terms? So maybe reorganize it just a little bit, because that's the way we like to see our polynomials.
Wait, I should probably just do this by hand, bruh. Do this myself. 3x6 and what's he doing? Plus. Do your first times your second. Is he doing the?
And then the question is, ways. Well, way number 1 is, what if we don't even consider it to be a product at the very end? What if we distribute those parentheses and make it so we just have a basic polynomial in this case? Well, if we do that, we'll get 3x to the 6th plus 2x to the 3rd minus 3x to the 4th minus 2x. Are you okay?
How do you do that so quick? Where do you get 2x to the 3rd from? No, wait. How did he even get 3x to the 6th?
Check for any like
Oh,
terms.
he multiplied them, didn't he? Oh, he did. Oh, shit. All right. All right, there we go. Wait, why is he multiplying them?
Do I have any like terms? So maybe reorganize it just a little bit, because that's the way we like to see our polynomials. And then the question is, can you take a derivative of that thing right there? Yeah, that's actually pretty easy. So if we do dy dx,
Hold on. Let me do this myself first. So you got this equals x squared minus 1 times 3x4 plus 2x 1, 2, 3, 4. Let me see, that's 3x6 plus 2x cubed, I think. I'm not looking at what he said or what he did. Minus 3x4 minus 2x. Yeah, that's exactly what he did. And then he simplified them. Alright, just simplifies to 3x6 minus 3x4 2x3 minus 2x.
the derivative of this polynomial, can y'all tell me real quick? Thank you, all of you. Appreciate it. Let's all try this. What's the derivative of 3x to the 6th? Okay, minus what? Then? Is that it? Okay, so that's our derivative. Now, the product rule should give us the same thing. And again, we're practicing the product rule in case I give you something like that, where you can't just distribute it. You'd have to distribute this one and then distribute. That would be very annoying. So we're going to verify with a couple of these examples that, yeah, you are going to get the same thing if you use the product rule. Do you remember what the product rule said to do?
Derivative of the first one
First one?
times the second one.
Sure.
Add the derivative of the second one plus the first one.
Yeah, that's very good. So I think the book has it in a slightly different order, but because of the commutativity of addition and multiplication, it really doesn't matter. As long as you take the derivative of one times the other, plus the other one times the derivative, like the derivative of the first times the second, plus the first times the derivative of the second. Or any way.
Oh shit. Hold up. Alright. I'm back. It's kind of hot, bro. Oh, it's not even plugged in, bruh.
You kind of permute that. That's fine. Take the derivative of one of them times the other, then multiply times that one times the derivative of the other. In other words, for us, we'd say the derivative
Damn.
of the first function times the second function. So that's our separation of the product there.
Just make sure. Alright. Alright, just making sure.
plus the first function times the derivative of the second. So derivative of the first times the second. Second plus the first times the derivative of the second. Second. That's how we like to say that. That's like how we like to see that. Are you guys okay on how this is coming about? Again, we can't just take the derivative of this and this and this and this. That doesn't work. Anytime we have a product there, we have to use a product rule, or we have to distribute and do it term by term. So far, so good? Can y'all tell me what's the derivative of x squared minus 1? What are we going to get out of that?
Zero one. So we fail to reject.
All right. Here we go.
So this will be our 2x times 3x to the
He did x squared minus 1 times 3x plus. Jeez.
the fourth plus 2x. Plus, do we take the derivative of this? This piece right here, folks.
2x.
No. Okay, so x squared
3x.
minus 1.
We do
Derivative of this. Can you take the derivative of that? 12x to the third, okay.
plus 2.
Plus 2. Cool. Notice how you follow the ddx. That ddx tells you what you're taking the derivative of. It says the ddx of this, yeah, but not that one. Not this one, but yes, this one. So follow the ddx. You'll say take the derivative of this little piece. If you can do that for these rules, it will really, really help you out. Raise your hand if you feel okay getting down that far. Now, is this...
18. Okay, so he has this plus this plus this. So he goes from this. So you got your regular, I think. Regular, or no, this is your derived one. Oh, he has it right there. Derived times regular plus regular times derived. This becomes a 2x. That's why it's out there. Oh, and then it just becomes 0. Bring this down. Bring that down. 12x cubed plus 2. All
It's
right.
the same as that.
Not yet.
If we distribute it, it should be though. Let's find out. Here we'll get our 6x to the fifth plus 4x squared plus, we're going to have to FOIL that, right?
Okay.
Don't worry, we're not done. We're like, wait a second. Oh no. Oh no.
No,
Just wait. Just wait. If we FOIL this, distribute it, we're going to get 12x to the fifth plus 2x squared minus 12x cubed minus 2. Well, at least I see the minus 2.
Oh,
That's
no.
fine.
How does he do this so quick, bro? Plus 12x fifth plus 2x squared minus x cubed. He really just foiled all that? The 2 doesn't. No. How in the hell? Six x fifth makes sense. Oh no, it does 4x squared. Yes. Plus 5. Okay, never mind. Never mind. We're good. We're good.
You guys okay with the distribution? Some basic algebra here. Now, if we do combine some like terms,
I'm gonna combine them. All right.
I see a 18x to the fifth.
Damn. I probably
Mine
split
is
it ends up.
The
Yeah,
second
it's
one,
gonna be that.
bam. Just look at these are the same derivative, right?
Right.
It is the same. This is just a different way to go about it. Of course, you like I said before, could you distribute that and do it this way? Absolutely. For this one, that might be the easier way to go about it. It's a product rule with just one parentheses, but as soon as you have some exponents, everything changes. And you definitely don't want to do this if there's some exponents associated. So keep in mind, we're building up to things, okay? We're not there yet, we're building up to things. I'm giving you kind of like the groundwork for the stuff we're doing later. So yeah, you need to understand the product rule before we get to something that's called the chain rule. Because then you're going to be using the product rule in combination with that thing, and in combination with the quotient rule, and in combination with these other ideas. So you do have to understand it, but I'm showing you right now that they are the same. It's just a different way to go about it. Do you guys understand the idea there? Also, have you read through the book, The Proof of this? The proof's in there. It's actually not a hard proof. There's just one little thing that they do. They add on an expression that equals 0 so they can factor it, and you can prove that the product rule works really well. Read through that. Let's do one more with the product rule. I'll give you an example of how some of the problems in your book are going to look. That way you can, so you have to replace go or something cool. Because when you do the product rule with that, the derivative of the constant goes to 0, and that piece falls out of the expression. Okay.
Oh my
First,
God! You got.
You need to be able to see that
There's
this
an X.
is in fact a product.
Here's a
Do you
root
see
in
it's a
there, bro.
product? What we mean by a product is not just like this, okay? This wouldn't be considered a product rule. Explain the difference between something like this and something like this. When I say product rule, I don't mean what's different between here and here. What is it? The constant, okay, even this. This wouldn't be a product rule. Not exponents. Not just exponents.
Grouped terms.
No, these are group terms.
You have two different groups of terms with the square root.
Okay, different terms that involve what? Constants or variables? Okay, product rule means we're multiplying variables. Okay, expressions that have variables in them. So this, do you need a product rule for that? No. No. That's just a constant. You could actually pull that outside of your whole derivative. The derivative of this thing is going to be 1 times 3. That's what it's going to be. Okay, derivative of x is 1, derivative of 2 is 0, 1 times 3 would be 3. That would be the derivative, right? So you get that even if you distributed the 3, that'd be fine. So we're not talking about products of constants times things. We're talking about products of functions in terms of x times functions in terms of x. Are you with me on this? Which is why we don't have to use the product rule when you find the derivative of that piece. That's just a constant times something. We're talking about functions of x times functions of x. You need to see the difference. Are you okay on the difference in that? You sure? So do we have a function in terms of x times a function in terms of x on that problem up there? Yeah, in fact, this is it right there.
Yeah.
Let me erase that 3. We don't need that.
Or we don't even do. Alright.
Let's go ahead and let's try to set up the product rule. Now, could you distribute it and do the work that way? Of course. Yeah, of course you could. You could distribute this to be square root of x plus x squared square root of x. You would have to combine some exponents there, but then you could take a derivative. Not too bad. Maybe I'll show you that in just a minute. If we do the product rule, however, why don't you guys figure out how to write out the product rule? Set up the d dx of the first expression times the second, plus the first expression times d dx of the second. I want to see that on your paper. I want to see the work. I don't want to see just the answer, okay? At this point, you're learning this stuff, so I want to see every step. I want to see it written out just the way I've showed you.
Yo. This guy's making me fucking do a square root problem, bro. Oh my God, I'm gonna lose. I'm gonna lose. Alright. Let me think. Why did my... d over dx. F prime of x times g of x. So if we were to hold up, oh my god, bro. Oops. Oh, this motherfucker never replied. So like just 2x root of x plus, assuming is it a plus, plus 1 plus x squared, and then x square root just reach x to the 1/2, so then it's just times x to the 1/2. My gosh, how does it even work? Oh, but because there's no, that's not it though. There's 1/2 x to the minus 1/2. Let's just see if he even has that first.
Derivative is plus 1. That's the derivative at this point. Derivative the ones.
Hold on. Yeah, I got that. Yeah, I got
So
that.
if we did.
Whoa. Alright, there we go. So, alright, then he's just gonna simplify it. I don't even know how to do this. Alright, 2x. This adds a 1, so it's x to the 1.5 to the 1.5. 3/2. Fuck, slow. 2x at 3/2 plus. I don't even know what 1 plus 2x plus 1 plus x squared. Or does that factor? There's no way that factors it right, left to right.
On the there's a we can do that because denominator 2x root x. You could combine those with fractional exponents if you wanted to.
Okay, that's what I did.
What's on the denominator of this expression? On the denominator of this expression.
Oh, the
on
one
the
half.
denominator.
The half.
There's a 2. There's for sure a 2 because of that 1/2. You see the 2? What else? Root x, because x to the -1, that says denominator, and then the 1/2 says it's a square root.
Okay.
1 plus x squared is on the numerator. Unless we want to get fancy and break that stuff up, find common denominators, we're just about done with that problem. How many people feel okay with this one?
Can we convert the square roots to fractions and then solve that?
Sure, we can do that as well. You'd have to distribute, from here you'd probably distribute that. You'd have 1/2 x to the -1/2 here, and you'd have, you'll get 1, you add those exponents together, that's the 3/2 for you. So I've just distributed and distributed. 1/2 x to the -1/2, and then 1/2, the x squared and the
That's
x
what I was
to the
looking at
-1/2 gives you
doing.
x to the 3/2. You alright with that? Then sure, you could combine these as well.
So you'd end up with like five
Oh my
halves
days.
over x to the 3/2.
Yeah, 5.
These guys, students are stinky, bro. They're trying to learn too much, bro. Holy. Something Evan would do, bro. Something Evan would do. You ever have that guy named Evan in your class and he should be trying to stink up? Let me see. You ever have that kid in your math class named Evan, bro, and he just be trying to stink up the class because he thinks he knows it all, and he just be trying to learn all these what's it called? What am I trying to say? Let me think. Oh, tired, bro. Fuck. You ever have that guy named Evan in your class, and that guy just acts like a smart aleck, bro? And he always just tries to do so much extra things just to, get on the teacher's good side, bro. That's what an Evan is, bro. What did this kid ask? Or whoever asked to do this is just being an Evan right now, bro.
5/2 over x to the 3/2.
Yeah, 5/2
This
x
fucking
to the
Evan, bro,
3/2
nowadays.
plus 1/2 x to the -1/2. If you wanted to leave it in terms of,
Now I gotta write this down because honestly I don't even know what my shoots. Do this real quick. Or 5 over x. Oh wait, let me try and distribute it though. So you got your times 1 plus x squared. Doesn't that literally just keep the same number because it's times 1? Yeah, it does. Alright. 1/2 x minus 1/2 plus if you got half on the x, 1/2 x, 1/2 x to the 1/2, 3/2. Is that right? It is 3/2. Where the hell did you get the freaking 5? Oh, he got that from. Where the hell did he get this 2? Oh, alright, yeah, so then the 2x times the x to the half results in a 2x 3/2. It adds 1. And then because they both have 3 halves, these things simplify to the 5. Is that another 3 halves? Why does he put 5 over 2? Oh, they add? We are adding these, so it is 5 halves. 5 halves x to 3x. And then plus, oh, that cancels out. So then this is now 1/2 x minus 1/2. Oh my days, bro. Stinky ass kid, bro.
Of exponents, that's probably what you would end up with, is those exponents just like that.
And that's an acceptable way.
That's actually exactly what you'd get if you distributed this and then took the derivative. If you just do it in your head if you want to. Think about it. If you distribute this, you're going to get root x, right? Distribute x. If you can't get that, do it later on your own. Distribute that and figure out those exponents. This derivative is that.
Wait, that's actually like so much easier
So
though.
this derivative is 5 halves extra 3 halves. It's right there. It's the same thing. Same exact thing. Feel okay with this so far? It's kind of in general. Almost like a little me that's very different, like a psychedelic butterfly. Like, what do you call it stuff? What is it?
Tie-dye?
Yeah, it was a tie-dye butterfly with non-straight edges and a non-straight outline. 4-piece jigsaw. You got it.
Two different pictures on different picture on each side.
Oh man, that'd be ridiculous.
Without
doing the product rule, you could have gotten around this problem. This one, well, you might still be able to do that. However, it's going to be a little bit easier if you do the product.
Okay.
If you have this, and I tell you only 2 things about it. I say
Yeah, I'm only halfway through the video. I've been going for an hour.
f of 2 is
Damn.
3. F prime of
Fuck,
2
wait, this
is
is actually gonna take forever. This is 40 minutes actually. It's gonna take like an hour and a half.
I'm not a spontaneous person.
Oh my god. I'm gonna be here all day.
Is -1. And I say find g prime of 2. That's my goal. Okay, well it's not too bad. What we're going to have to do though is figure out some pieces to fill in. We want to find the first derivative of g and then fill in the 2. Do you follow me on this? So let's go ahead, let's use the product rule. Firstly, do you see why we need the product rule here? Do you see it? Do you see why? Do you have a function in terms of x times a function in terms of x? This is a function of x, yes? This is another function of x and they're being multiplied. That's definitely the product rule. So what I'd like you to do, just follow the product rule with this. Go ahead and do that now. Follow the product rule. I want you to find g prime of x. Derivative of the first times the second plus the first times the derivative of the second. Just write it out.
Well, that's my hour marker, bro. We've been here for an hour. I want to eat food though, but I don't think I'm allowed to. Oh my god, we're doing another hour, bro. Fuck! I'm gonna eat food after next hour. Alright, wait, what's he want me to do? Example. We've got g of x equal x squared plus 1 f of x. F of 2 equal 3. F prime of 2 equal -1. Fine. What do those have to do with the finding the g prime of 2? G prime of 2.
derivative of the first times the second. Yes? Plus. The first times the derivative of the second. If you want to use d dx, you can. Would you agree that that is in fact the product rule for this problem? Derivative of the first, yep, times the second, okay, plus the first, got it, times the derivative of the second. I don't care that the function's not listed. It's f of x, so whatever that happens to be, that's what would go here, and that's what would go here, just like in our other examples. You with me?
Why do we just have...
Well, let's do the
F of x.
derivative where we can. Give me the derivative of x squared plus 1.
2x.
So this is 2x times f of x. True?
Okay.
Plus, do you take the derivative of that?
No.
X squared plus 1 still needs to be in parentheses, ladies and gentlemen,
F prime of
times,
x.
what's the derivative of f of x?
F prime of x.
Aha, f prime of x is how you write that. We don't have the actual function, but you know that f prime of x stands, this, would you agree, is g prime of x?
Yes.
That's a derivative of g. That's what that is. What we want
Now
to
we
find
second
out
two.
is g prime of 2. What does g prime of 2 tell you to do?
Put 2 in that's all the x's.
Everywhere you see x, plug in 2. Everywhere you see x, plug in 2. Everywhere. So for us that means
Oh,
Tell me
I
what I
understand
should
it
have.
now.
2 times 2, great, because x is 2, fantastic. Times f of what?
So then...
That's everywhere you see the x, correct?
Let me just put in the... Now we got that. So this is really just... 3 times 2. And this is just negative 1 times 2. So 4 times 6 plus 5 times negative 2. So this is 10 plus, negative 10, which is just 0. Bro, we did ass. 7! I fucking did my math wrong. That's embarrassing. F prime of 2.
Hey, what happened to all the x's? They became 2's. This x became 2, therefore every other x became a 2. Raise your hand if you feel like that so far. So it's kind of just a little exercise so you get used to the product rule and then filling out the numbers with the substitution. Let's go just a little bit further. There's no more x's. We can now make some substitutions. I know that this is 2 times 2, so that is
4.
4 times 3.
4 times
Plus
3? Oh, it doesn't multiply, it just becomes it. Alright, bruh. Interesting. Times 3. 4 times 3 plus
This is all 5.
5.
5
Minus
times,
1.
what's f prime of 2? Cool. Is it possible?
12
Sure, yeah.
minus
They
5.
have to give you this,
Yeah,
though.
7.
They have to tell you what that is. I wouldn't be able to the curve at that x value. So what you just found, this is actually a slope. The slope would be 7 of that curve, whatever it is, at x equals 2. You see that? Kind of neat. We're finding slope. Always keep that in mind. What you're doing is you're finding slope.
Oh,
You're finding
Step up back, bro.
Nope. No, we might be able to figure it out. Or at least something that represents it, but no, we don't know. Hey, ladies and gentlemen, are you okay with the product rule? In general, it's really not that hard of a rule. If you have this down, that's it. The idea, but it's that.
Oh, the quotient rule. Alright.
Quotient rule. Quotient rule asks this question. Says, can you take a derivative of a quotient? Something in terms of x over something in terms of x. That's what this question is asking. And the idea is, well, can I just take the
doesn't look
derivative of
fun,
f
guys.
and divide by the derivative of g? Do you think that's going to work? No, that never works. We can't separate derivatives by multiplication unless we use a product rule. We can't separate derivatives by division unless you use the quotient rule. Are you with me on that? You can't just take a derivative of the top and the bottom. That's never going to work for you. I give you a very simple example about how that's never going to work for you. If you did that, you'd get something over 0, true? Yet we know that this would be the same thing as 1/3 x squared minus 1/3. True? Derivative would be very easy there. 2/3 x, and that's it. So we can't just take the derivative of the numerator and the derivative of the denominator. That doesn't work for us. We have to have some other way to do it. By the way, you probably wouldn't, you could, but you probably wouldn't want to use a quotient rule for this very simple example. You'd probably break it up, just like I did here, and then you take a very easy derivative. The quotient rule and the product rule are really meant for some more extensive ideas, things where you don't have other ways to do it. That's really the benefit of these rules. So I'll show you what the quotient rule says. Quotient rule says, okay, in order to take the derivative of a quotient, we're going to take some derivatives of each piece, but we're going to put them together in a unique way, just like we do with the product rule. It says you're going to take the bottom function times the derivative of the top function. I'm going to use some logic that's not quite mathematical, but it's going to make you remember something. Product meant plus, right? P with P. Product meant plus. What's the opposite of a product?
Minus.
A quotient. What's the opposite of a plus?
A minus.
So what are you going to use here, plus or minus?
Minus.
Okay, it's not very mathematical, but that's the way you remember it, okay? Product with plus. Quotient, I think quotient has a straight line, so quotient has another straight line. Quotient minus, that's how I remember it. Actually, I remember it because I've done this so many times, I can't forget it. It's stuck in my head like jingle bells.
Jingle bells.
I have a song for that too. The math song for Jingle Bells. Just watch my videos, you'll see it. Quadratic formula song, that's right. Minus the times the derivative of the low function, all over squared. Or if you prefer, if you like the DDX format like I do, this says the same thing.
Or
That says the same thing.
dx.
Oh, there is. There is, and you know what? I think
Hold up,
like
I knew
it, so
Evan.
I'm
I know
gonna
Evan
steal
just
it from
spoke again,
Michael.
bro.
Oh, there is.
What did he say? Evan
There is,
definitely
and
said
you know what?
something. Turn up the volume. See what Evan said, bro.
That says the same thing. Oh, there is.
Yeah, I can't pick up on it.
There is, and you know what? I think I liked it, so I'm going to steal it from Michael. So
No,
he
they name
introduced
dropped.
back
It's
that
Michael,
before,
not Evan,
but
bro.
It's a good. It said, what's it say again?
Low D high minus high D low, square the bottom, and away we go.
That's right.
What the hell?
Very cool. Low D high minus high D low, square the bottom, and away we go. But you have to do this with it. Otherwise it's gonna That's a Harry Potter version of this math. Yeah. Low D high minus high D low, square the bottom, and away you go. Yeah. Derivative of the bottom, derivative of the top times the bottom, or the bottom times the derivative of the top, minus the top times the derivative of the bottom all over the bottom squared. That's really what you're doing. Low D high minus high D low, square the bottom, away you go. Sound good?
Is the first one supposed to be the bottom, or can it be the top first? Yeah.
Hang on.
Can you do that?
You mean, can you interchange these two?
No, the side, from left of the minus sign, right.
Can you interchange these two?
Yeah.
Absolutely not.
Yeah.
Because subtraction is not commutative like addition is. Okay, if you interchange those, is 5 minus 7 the same as 7 minus 3? I'm sorry, that's not even close to the same thing. It's 5 minus 7 the same thing as 7. No. So if I just interchange, you're like, wait a second. No. Top times the derivative of the bottom minus the bottom times the derivative of the top. That's what you're asking. Multiplication is.
I'm
key.
so
I like the new one. Got it?
hungry.
I'm not. An example. These are slightly different than the product rule because some of these examples can't be done
Let's
without the
got
product rule
examples. Let's move on to the
at
next
all.
example.
You'll see it. It really isn't all that.
Alright, let me try this out. Try this. Oh my god, I just want to eat some food, bro. Shit. Shit. I want some food, bro. Alright.
That hard. I mean, you know pretty much everything there is to know at this point about taking simple derivatives, right? Move the exponent to the front, you take one away from it. That's a derivative of basic functions. Now it's just using the rules to split these up into little
Oh my
pieces.
gosh, wait. I've got to. Oh, hell nah, Jigsaw. Alright, you do equal low, which is 2x plus 5, low, then derivative of the high. Okay, I'm not gonna lie. That does sound like a little helpful. Minus 6x minus high, which is the x cubed, minus 3x squared minus 5. Load the elements ID low. Alright, now I gotta derive 2. Oh, it's just 2. Oh. Over. Is it just 2 times 2 is just 4? Say
To
swear
make
to
it
God.
easier. So if you know the problem, you can separate one zeros.
Say swear to God.
That can
Wait,
help
why do you add a
us
5?
Separate it, simplify
Wait, am I
the
slow?
fractions into, so combine exponents, and then take a derivative of each little piece, and that's fine. However, as soon as you do this, can you do that anymore? Well, you can. You can separate 3 fractions, but it's not simplifiable like you did before. You can't say x cubed over 2x
let me
plus
think
5
Kabos.
is one term. You can't do that anymore. You can't separate this 2x plus the 5. You can't do that. You see what I'm doing, right?
Blah 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 blah. Let's see. He don't. Is he just? Yeah, he's just laying out this stuff. Does he mean to derive those two? That would still be 4, right? Let me simplify now. 6x cubed minus 12x squared. Yeah, 6x cubed minus 12x squared plus 15x squared minus 30x. Holy. Let me make some more space. Minus x cubed minus 3x squared minus 5, or no, 10, minus 10. All over 4. Days. Damn.
Distribute.
Oh my days. I get to eat sooner. Please, please. Oh my god, I think I already messed up. Wait, no. Oh wait. Oh, he's simplifying now. Wait. 6x squared. 6x cubed. Minus 12x squared. Plus 15. Minus 30x. Minus x. Oh crap. Where did he get that? He got that. Why did he do that though? He didn't have to derive that. Minus x squared minus. Why did he derive that? He didn't. It wasn't just the g. Oh my gosh.
That's different than this. So show me the parentheses where they're applicable. See with that. That was it. It's a negative and the 2. So minus 2x cubed. I actually heard none of you. I'm just doing this in my head. Thanks a lot, guys. Appreciate it. That's okay. I know you know how to distribute. I'm going to do both these at the same time, the negative and the 2. So minus 2x cubed plus 6x squared.
Oh, I'm slow. All I did was distribute, bro. You didn't freaking. Alright. Oh, we'll do that. But, yeah, I guess it does derive to that. Okay. So minus 2x cubed minus 6x squared minus 10. Does it over 4. This is now 4x cubed. Thank you. See that. What's now? Oh, my head hurts, bro. Minus 18x squared. Oh my days, no, that's minus 3x squared. Minus 30x minus 10 over 4.
Plus 10.
What? Why did that not, brother? Bruh. 2x plus 5 squared. Why didn't that become a derivative? Noah 5254. Noah. No. Let me. You in VC? Are you in VC right now? Are you in VC? Oh, Takashi. TK-san. What? What? You bum? I don't know if I can show my gifts on here. Alright, honestly, I probably shouldn't miss. Do your work. What? Oh hell no! It's a crisp 75. I know. I should be outside, bro. What the hell are we doing, gang? Hey, but tell TK to go outside, bro. What's in the actually? Nah, I shouldn't have showed that. I got you. You're not coming to my house to do You're not coming to my house to do calculus, bro. You're not coming to my house to do calculus. I'm genuinely not gonna get work done, bro. I swear to God if you pull up, bro. Oh my God. Alright, bro. You better bring food, bro. You better bring food. I'm hungry as shit, bro. I'm hungry, bro. Alright.
Oh, doubled that one. Minus 30x.
Wait, why is that plus 10, bro? Oh, the negative. Oh, my head hurts.
That's your derivative. What did we just find?
Thank God.
What's this?
What's
that stand for?
Shut up.
That's derivative. What's the derivative stand for? Slope. 1 point.
I'm surprised you didn't want to simplify that even more. Oh crap.
If I asked you to find the derivative of that, do you see how firstly there is a product rule? Function of x times a function of x. That's product rule. Then when you go through that, as you're doing that, that's the first thing you see. From the outside in, you see a product rule, right? As you're going through the product rule, it would be derivative of the first, that'd be fine, times the second, still okay, plus the first, all right, times the derivative of the second. And as soon as you get to the derivative of the second, how do you take the derivative of that thing? It's a quotient rule. You would have a quotient rule that is within the product rule. See that? So we're going to talk a lot about this, how the rules will have an interplay, which ones you do first and which ones you do second. Basically, if you can follow the DDX, follow the first rule, then follow the DDX, and wherever you have a quotient, then use quotient rule, or then use the product rule. We'll get there.
So, man, so we're gonna do this. This is the final
Probably
boss,
get
bro.
there right now. Let's try one. ADD is only on math. All right. Now, we're going to do this the hard way. We're going to do the hard way because I want you to see it. But there is an easier way to do this. The easier way to do this would probably be to distribute this, combine like terms, and then use one quotient rule, right? But I want you to see how the product rule will play in this. Because if I do one thing, you can't do it anymore. If I gave you like a 5, well, you definitely wouldn't be distributing that anymore, right? So you better learn the other way, because I'm certainly going to give you something like that. You're going to need to be able to do it. So we're going to learn how to associate the product rule with the quotient rule and use a rule within a rule right here. Now, when you look at the first rule to use, you got to see which one's overlined, encompassing more of the problem, the product rule or the quotient rule. The quotient rule clearly is. It says the product is actually within that quotient. Do you see it? So the first rule we're going to use is quotient rule. Let's write out the quotient rule. What is it again? Low D high. Low. What says my low?
X squared minus 2.
Do I do anything to the low right now? Low. Then what?
D high.
D high. So we're going to do D high. Oh, nasty. Low D high. And then what?
Minus high.
Minus. Okay, like the minus. Low D high minus the high. Okay. Real quick, I'm going to show you the board here real quick. Make sure that when you distribute this, you still have a bracket. If you distribute, you still have a bracket, because that negative will ultimately change those signs. You see what I'm talking about?
Gosh. Low derivative. Just do this. Derivative high. 3x. It's just 3x, just 3. 3 times 2x. Low D high. Low derivative high. Minus high. Oh my days. 3x minus 1. 2x squared plus 4. Low D high minus high D low. Derivative low. Derivative 2x over low 2x plus 2 squared. Please don't tell me this guy's actually pulling up, bro. I forgot to my dog. I'll be over in 40, bro. Gosh, I don't even know how many. Oh, we haven't even done the homeworks yet, gang. Oh my gosh. I gotta. Okay, this just becomes 6x. This is actually gonna clutch. 6x. So what am I doing here? 6x cubed is 12x minus. Oh my gosh. What in the hell is this abomination? Okay. 3x cubed plus 12x minus x squared minus 4. Then you just got your 2x on the outside. You not have to put into every single one. 6x 4 plus 24 x squared minus 2x 3 minus 8x minus 6x cubed plus 12x over x squared plus 2 squared. Now I gotta simplify this. Minus 6x4 plus 4x cubed plus 24x squared plus 4x over x squared plus 2 squared.
Important.
Come
So,
on, give it to me!
you know that-
Give it to me!
like, you see, it works after just
What? What?
and distribute, and then distribute, and then distribute, and distribute. Don't forget the negative, and then combine all those like terms. Use something pretty nasty looking, but it would be a polynomial in this case.
What? He didn't even finish it. Alright, time to ask the Menai, bruh. The Menai. What do y'all know about the Menai? We don't talk. What is that? That's a mountain bike. What's that? What would this simplify to? Oh my head, bro. 75 degrees out, bro. I should be doing some, bro. But GPT wrong, bro. I mean, the Menai wrong, bro. The Menai is wrong, bro. I'm already telling you. What are we talking about? What did you see? What did you see that I don't see? Okay, wait, actually. 3x squared plus 4. Oh, shit. Plus 2x. 3x minus 1. Minus 3x minus 1. Oh, shit. X squared plus 4 times 2x. But that's what I had, though. 6. Oh, crap. Oh, shit. Yeah, I already messed up, didn't I? I messed up. Yo. Wait, what? First distribute a 3. X squared plus 4. Distribute a 3a. Alright. I have the idea down. That's all that mattered. That's all that mattered, gang. That's all that mattered, gang. Alright, now. Holy crap. Oh my gosh. This is my homework, bro. Let's get some grub in, though. It's time to eat. It's time to eat.
Differentiate the function f of r is equal to 5 over r cubed. Let's start by writing this as a simple polynomial so that we can then apply the power rule.
Taking the jokes are scripted.
You'll never know. And you're thinking, was that scripted? Raise your hand. I'm not spontaneous.
Want to talk about the product rule for differentiation. This is not simple. Derivative of a product is not the product of derivatives. A limit, it is. The limit of a product is never going to happen overnight. It took someone forever to figure this. They played with it and played with it and played with it. The factor out is 1 squared. Probably wouldn't multiply it out, and it just saves time in writing. Quantity x squared minus 7x plus 1. Now when we're looking at this function, we apply the rule, turn our attention tangent line at the ordered pair -1, 1. The numerator function 2x has a derivative of 2, and the denominator function x minus 1 has a derivative
mic was off. Oh my gosh. Bro, we didn't even go over this. What the hell?
In this exercise, we are first asked the question, how is the number e defined? And the number e is the number such that the limit as h approaches 0 of e to the h minus 1 divided by h is equal to 1. And so that is how the number e is defined. And then we're also asked to use a calculator to estimate the values of these two limits correct to 2 decimal places. And then we are asked what can we conclude about the value of e. That we are given to the h, estimate.
Where the hell?
So 2 negative values and 2 positive values. And with these values, even though we are getting closer to 0 approaching from the left and also closer to 0 approaching from the right, is estimate to the h minus 1.
Differentiate it. Let me see what I want to do the actual problem. Nine over R3. This is not just freaking. Wouldn't this? How would I solve this? Don't tell me the answer. Oh my gosh. Isn't this just quotient rule? Love that you want to figure it out yourself, blah blah blah. So this is x. Oh, I'm slow. Is it really just you bring the r up? Oh, I'm not gonna look at the rest. But as you bring the r up, it becomes a -3. Bring it up front. That's 27r minus 4. Is that really it? Oh, that definitely just changed up something on here. Or not. R. Check this. Oh my god, bro. Oh, is it no? Negative? Please tell me it's just negative. Alright. Then it's kind of the same for this one. Hey, you bring up the R3. So it's now 8R3, 24R squared. Alright, bruh. You mean? Oh, it became negative again, bruh. I'm dumb. Alright, 8R minus 3 minus 24R minus 4. Alright. Clutch. Differentiate the function. I think. RT minus 4 RT minus 4. Yeah, there's no way, it's just What's the product rule? Look at my notes. Try that real quick. I don't like how they gave me the questions, but it just seems weird. It's just 5 times 5t minus 4 plus 5t minus 4 times 5. 25t minus 20 plus same thing, 25t minus 20. 50t minus 40. There's no way. Oh my days, I actually got it right. I'm actually kind of surprised, I'm not gonna lie. I don't know how to do stuff with ease, bruh. But I think I can do number 5. Oh crap, I can't get rid of my work. I actually need my work. Calc 3.1. Work. All right. Differentiate the function. Y equal. No, I can't do that one. What the hell? Here we go. P of W. I don't even need the P of W. I just need to write it out. 4W squared minus 2W plus 8 over the root of W. So this is a quotient rule, I think. Low, let me put the W's a half. Low, derivative high. 4W squared minus 2W plus minus high, which is 4W squared minus 2W plus 8. Derivative low. Over W squared. Oh man. Jeez. How the hell am I supposed to differentiate this, bro? Holy. Alright, we'll start off with W times 8W minus 2 minus 4W squared minus 2W plus 8. Oh, and then for the root of this is 1/2, bring it out to the front. The hell? Let me think. So this is 1/2 W minus 1/2. And then multiply this. So this is yo, there's no way. Yo, yeah. Yo. W, yo, go to call out, bro. Holy. I know who this guy is, bro. It's my friend. There's no way. Jesus Christ. Yo, I feel like he's gonna come back. That's actually crazy. What the hell? It's one of my friends, but I didn't think he'd actually freaking do it. Oh my days. Dude, I actually gotta do this calculus work though. I can't. Fuck. It's way too much calculus. Yeah, I actually can't. I feel like he's gonna pop up any second now, bro. He's emoting at your. Actually, he just knocked on my door. Hold up, I'll be right back. All right, What do you mean? They saw you through the window.
What were people saying in chat? There's someone in your window?
Yes, bro. He said. Someone said he has been emoting at your window for like 10 minutes.
Hold on.
Scoobert.
I walked in his house, and his sister was here, so I ran away. I would like to pledge this victory to Omnom.
Who?
Omnom, bro.
What are you talking?
Thank you, everyone. Thank you. All right, now we're gonna teach you calculus, bro. All right. You got a whiteboard.
You're gonna teach.
I'm gonna teach you calculus. I need a whiteboard.
Alright, we'll be back.
No. We're gonna stream this.
I know. Hold on.
Hey, we're gonna turn the lights on. Make it party time in here.
You want to use the iPad or?
We need like a whiteboard or something. I need to like show you how to stuff. I'll see right now, Scoobs. Don't worry. I'm checking. Yes, he does, Scoobs. He does. Go ahead and restore that guy, bro. Give him a restore. Go ahead and ban him, Scoobs. Okay. So I'm gonna teach you all how to do some calculus. So we see right here, we can see right here that we're trying to find the derivative of 4e to the x plus whatever the hell. So what you're gonna want to do first of all is you never take a derivative with something in the denominator. So we're gonna have to rationalize this. So where's his pen? You live in a slum. Where's your pen? All right. So
It's right here.
oh, all right. How do we set this up?
So what up?
How do we set it up so the stream can see? Hey, chat.
Oh, I have no idea how you would.
Alright.
I just have the whiteboard for you, bro.
We do this? Oh, shit.
What?
Why are you cheating?
No.
Okay. Alright. So, you know what a derivative is, yes? So, when you take a derivative, you obviously always want to have this is going to be like your normal function. So, your normal function, you always rewrite it. So, 4e to the x plus this 5 over the cube root of x. So, whenever you're taking, hey, lock in.
Let me charge this stuff real quick.
Lock in. Whenever you're taking a derivative, you never want to have anything in the denominator because then you're going to have to rationalize. What you should do initially is rationalize it. So, when we go here, we're just going to rewrite it as this so far. We're going to go, well, this equates to just being, as we rationalize by putting the cube root on both bottom and top. What's up, man? So we then go 4e to the x plus 5 cube root of x. What's up? I'm teaching them how to do calculus. So next off, we take the we differentiate it. So we go f prime of x goes to 4e to the x, because e to the x differentiated is always the exact same. You can literally just pull this out and you get the same exact thing.
What's the 4EX?
E to the x, anything you, so should you integrate e to the x or take a derivative of e to the x? You always just get e to the x. So
Okay.
these two are, the e to the x is like, if you ever see this in a differentiation problem, don't do shit. Just don't even touch it. It's always going to be e to the x no matter what.
Alright.
The next one is, derivative. You have to use the quotient rule. I'm fucking stupid. Don't do that. Don't do what I did. That's only if you have a multiplication of it. What you should do is, if you want to take derivative of this, you do the quotient rule. So you do, what's the...
Low D high minus high D low.
Yes, sir. Low D high minus high D low. I was looking for that. So what you should do
Oh,
is...
let me switch the microphone real quick.
Is the microphone not on the big one, or is it on your... you got that thing?
I have no idea. It's either on. Yo. Oh, wait. Oh, it actually is on. Alright, never
Okay,
mind.
it don't matter. It don't matter. Come on, lock in.
Alright.
So what you do now is low D high. So let's try this out. We'll take the low. So cube root of x. Shit, is it plus D high? It's low D high.
It's multiplied
It multiply
by the 5 minus
minus high
5.
D low. What is the derivative of that?
It's gonna be 1/3 x to the minus 2/3.
Sure about that?
Let me see. Let me write it out at least. Yeah, I think it's this.
Are you sure?
Yeah. Oh. Yeah, should be that right.
This is your final answer.
Yes.
You disappoint me.
What?
Your answer will be 1/3 x 2/3. So, how you get this is...
Wait, no, don't you have to subtract?
No!
Why?
So, let me get to it. Let me
Okay.
get to it. This is calculus. You're learning calculus here. What you do is it's always going to be, we'll say you have a square root of x to the n.
Okay.
We differentiate this. This is the f of x. I just can't draw. We differentiate this, and guess what? This is an n, by the way.
Okay.
We go, whatever this number is, it's going to be 1/n times x to the power of 1 minus n.
Yeah,
Yes.
that's what I did.
No, because you put 1/3. It's 2/3. 1 minus n. What is 1 minus 1/3?
1 minus 1/3 minus 1/3 minus 2/3. Minus.
1 minus 1/3, Nicholas. 1 minus
Oh.
1/3.
2/3.
All right, let's get a clip on that. Yo, can we clip that, chat? Yo, chat, let's clip
There's
that.
no chat, bro.
Chat, let's clip that. How do we
There's-
clip it ourselves? Clip. We're clipping that. It's your first clip, bro. That's your first clip. Come on, give me some. We're already clip farming. You shut the fuck up, Scoobs.
Who?
This, my friend.
Fern?
Dumb ass. Where's what we're gonna name it.
Alright, bro.
Alright. So, anyways, we have this. Now what's this over?
Low, so,
Low squared. Come on. You're
Low,
not
low.
thinking. Low squared. Low D high minus high D low. All over
Low,
low
low.
squared.
low and low square.
What
Those
is-
are the same
what is the
things!
cube root? What is the cube root of x squared?
Cube root of x squared? What do you mean?
I meant, fuck. What is what is the cube root of x squared? Yes, that's what I said.
The cube root of
Of x. Cube root of x squared. What is
2/3. X to the 2/3.
Let's see your thinking. Let's see your thinking.
Low.
Okay, what is that?
Root or cube root x times cube root x.
What is that?
You want me to derive it?
Yes. Well, not derive it. You expand it.
Then it'd be like x to the.
Okay, what is it?
X to the. Just 2/3.
Oh my god, you can do math. I am so proud of you. Congratulations! 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 We are in Evangelion. Nope, keep the cap on. So, now that we have this, we now bring it back up to this original equation. And we put 5 cube root of x minus 5 over 3 x to the 2 over 3. All over x2 over 3.
Okay, and then do I just input that in?
What would you like to do with this? Oh shit.
Oh, shit.
What is the solution?
Yeah, what do you. Prime.
Well, let's look at what the question's asking you before we continue.
I mean, I just gotta put it in, no?
That's what she said.
All right, bro.
Yes, put in your answer.
I still don't explain the e though. Like, what?
You don't touch e. No matter what, any derivative or integration of e to the x is always going to be e to the x. If you have e to the x if you have e to the 3x, then it's going to be 3 times e to the x. E to the 3x. No matter what, you never touch e to the x. If there's something as a coefficient of the x in the e, then say, let's go. We say f of x is equal to
Fuck.
e to 3x. We then say f prime of x. Keep doing your thing.
Okay.
Conversely, we say
This is 5/3. What is this? 5/3 times?
5 over 3 x.
What the fuck?
Tell me what's wrong with it.
Am I missing the e somewhere?
Oh.
I didn't even realize that's what you were going to call me. I was just going to call you fucking stupid. Nope! Wrong spot!
You can't move it down. There's freaking oh. There's no way.
So, next up, this is what you do.
What?
You take a screenshot of the problem, and you put it into
the
this.
Menai? The Menai?
The big Menai.
The Menai.
The big Menai. Please speed, I need the... Bro, teaching you calculus has been going...
After. My brain's melting from this. I'm too stupid to understand math. Who is Fern of the Halls, bro? That's your friend? Yo, what are you about to flight? Hi, meme. What do we do?
So what the fuck is the answer?
Assessing user frustration.
Okay. Alright. Oh, thank you. Yes. So I'm gonna
listening to all of this, dog. I appreciate this front of the halls.
Okay. So I'm just gonna do this right here. We're not gonna have it like that. I'm just gonna do this like right here though. So what we're gonna do is e to the x cube. So differentiate. Differentiation of k squared is going to be. Oh, you told me to not give you the exact answer on the previous problem. What are you? Are you good? Are you a good student? You don't like fucking cheating?
Try to be.
So let's read about this, by the way. Right here. For the second term, 5 over 3 over the cube root of x. We're going to use the rewrite first strategy from your previous problem.
I don't even know.
So what we're going to do is we're going to rewrite, say, x. So, okay. First of all, you need to know this. The root of any number, so the root n of a number x is going to always be the inverse of it will always be x to the 1 over n. So if we have the cube root of 1 over 3.
Yes.
Okay. Now, look at this. See how it says it makes the term like this?
If it's negative, doesn't it go up or down? Is that what you're trying to say?
No. No matter what, if you never want a
Exponent of
an exponent on the negative. This doesn't even use the chain. This doesn't even use the fucking
quotient.
What? Your
this software sucks, bro. Like I'm telling you, I'm genuinely just freaking set up for failure, bro.
Power rule. So derivative of the first minus. Math major, by the way. Multiply the front coefficient by 5. Yes. You take derivative with respect to x. This turns into 1, so it's 5 times 1 over 3. Taking the derivative of with respect to x, this would I wrote this wrong, but we'll say that, and then we'll say the thing right here is going to be 4e to the x plus 5 1 over 3. So this is going to be your first one because we take the derivative of the outside.
Okay.
So power rule is first times derivative of the second. So if we have x, y.
Yeah. It's
the power, if we take the derivative without like a respect to anything, we just
derive first one times regular plus regular times first one now.
If we take derivative of this would then be 6x squared plus.
Is there 6x?
This is the same fucking. Ah! Okay, so the next one is you subtract 1 from the exponent.
Okay.
So the exponent then goes into 5, 1 over 3 minus 1. So this turns into
negative 4/3.
5.
Negative 1/3 minus 1.
That's not negative 1/3. It is negative 1/3 because we. Good catch. But why is it negative 1/3? Good catch.
Because of the root.
Stop looking at the answer.
Because of the roots.
What root? What does the root have to do with it?
It turns it into 1/3.
Okay, but why is it negative 1/3?
Because it was probably on the denominator. You have to. It's either on the numerator you bring it down, or it's like one or the other, and you have to freaking push it up or down.
What is that called? What? Okay. What is different? We'll say. What are these two? What relationship do these two have?
Yeah, I can't tell you that.
So,
You just divide by 3. I don't know.
So, this is an inverse relationship. Say if these both increase by a factor of n, we then say n over 1 can turn into 1 over n to the power of negative 1. The power of negative 1, what that does is it'll flip it and then turn it into n over 1.
Okay.
Okay?
Okay.
So, why is this negative? So we'll go back to the original equation of 5 over the cube root of x. Why does this turn into 5x to the negative 1 over 3?
Because you brought it up.
Okay, why? Why did I bring it up?
You don't want, like, because obviously you're going to transform this x into the x to the 1/3 because of the root. No?
Oh, no, I was looking at the camera. I was speaking to the audience.
Alright, bro.
Go.
What?
What's up, man? I'm teaching him how to do math.
I heard.
Alright.
Can you drive me to practice? I can't drive.
We're in the middle of calculus, bro.
I need to go to practice, bro.
Then drive yourself, bro.
Mama's gonna yell at me.
I don't know what to tell you.
Yo, if I drive myself, I'm gonna tell her it was your idea.
Okay.
And you're chill with that?
Yes.
Bet. Alright.
Good work.
Right.
Anyways, this is negative because it's on the denominator. So as I said, we'll say 5 to over n if we always want this. If we can avoid using the quotient rule, we always do because we are lazy as shit as math majors, or math people in general. So what we do is we just turn this into 5n to the negative 1. And then we also put this in parentheses because it's not, well, it's 5 times n to the negative 1, but because we want to specify that it's not going to strictly be 5 n to the negative 1. We want it to be 5 times n to the negative 1. Because then, once we're done with our derivative, we then turn this into fucking n. Let me get rid of that.
Sorry.
And that's the derivative. So, anyways, when you take derivative, you always subtract 1 from the exponent. So, we'll say f of x here, this is going to be x to the 1/3. What do you do when you take the derivative? What does this turn into? Let me pitch you an easier one. All right, you ready?
Okay.
X to the 3rd. What's the derivative of that?
3x squared.
All right, that's good. That's good. What about 5x to the 5th?
25x4.
Oh, you're getting it. You're getting it. What about x to the 2 over 5?
2/5 x.
Wrong!
What do you mean?
That's wrong!
How?
What is the answer?
The derivative of x to the 2/5?
Yes.
2/5 x and then minus.
Let's ask your trusty friend here. What is the derivative of x to the power of 2 over 5? How do we make it answer quickly?
Flashlight.
That's all we need. We just need it to answer quickly. Ooh.
What?
Ooh. That's completely incorrect, by the way.
Actually?
This is completely incorrect. What the fuck? This is completely incorrect. What? This isn't even what I asked it. What? Oh my god. What is the derivative of x to the 2 over 5? What is the answer? What is this answer? Don't look at the screen. Don't look at the screen. I said don't look. Don't look there either. Where's the pencil? Pick up the pencil. You disappoint me. Get the marker. Not with your toes, you goblin.
Yeah, legendary Toad reveal, bro.
Marker me.
Marker you.
Take the tip off.
Alright, bro.
And put it on. What is the answer? No, don't look at the monitor.
2 over 5x to 3/5.
All right. So the answer to 2 over 5x, or the derivative of x to 2
That
fifths,
makes sense.
is x 2 over 5
Yes, and then you extend your line. For
x 3 over 5. All right. Let's do an easy one. I'm gonna give you an easy one.
I'm not learning anything.
3 over 2. What is the derivative of 3 over 2x?
So do you put your?
I don't know. You tell me. Let's see the thought process. Come on, draw it out for me. Draw it out for me.
Well, I mean, because like 3 is bigger now, though. 3 is bigger than 1/2, though.
But bread tastes better than key.
It's probably gonna be like. It's just 1/2.
Ladies and gentlemen, he did it. I can't believe this day. He did it. We're opening OBS for this one because I need to make sure it's on there. He did it. Look, is that on the right side? No, this is the right side. He did it. The derivative of 3 over 2x is 3 over 2 times x to the 1/2. I can't believe it. Oh my god. Oh my god. 4 quarters.
What?
Those who know ball. Those who know ball. So, let's get right back to it.
Oh.
We'll say 5x negative 1 over 3. What do we do here?
But you're gonna have to multiply the 2 now. You're gonna have to.
Let's take this piece by piece, okay?
Okay.
Piece by piece. We'll take these into groups. What is the derivative of 5 with respect to x?
0.
0. Correct. We'll do this. We'll make it so the audience can see. What? Okay. You said the derivative of 5 with respect to x is 0. Okay. What is the derivative of x? 1 over 3. Negative 1 over 3. Using the same math that you did before.
Is it gonna be like?
I'm gonna give you a chance to restart. Okay, it's okay. Hey, it's okay. All of us start from somewhere. So, let's go back to this part right here. When we took derivative of x 3 over 2, what did we do? What was the first thing that you did?
We brought it to the front.
Yes. Now, what do you have to do here?
Bring this to the front.
I'll give you a chance to draw that properly and not draw an omega sign.
The what?
Greek symbol. 1 over 3. Not 5. 3. Thank you. Now, what do we do next?
Let's see.
We note that the exponent is not 1, so the x remains. We have to note that. But this is where we do side work. Okay?
Okay.
So let's bring it to the side over here. Put it right here. What do we do here? What's the next step after we write down what the coefficient is?
You want to subtract anything you have here?
Subtract what?
Subtract 1 from it.
Alright, what do we do? X, negative 1 over 3.
Minus 1.
Minus 3 over 3. I can write. So what does that give us?
Minus 4/3.
X to the negative 4/3. What do we see in this? I can tell you what I see. I see a bright and intelligent young man who can set his sights on anything and do whatever he wants in the world. But what do we see in this?
There's another. I don't know. Oh, you can. It says it's negative can be brought up to the one up here.
So here's what we're gonna do. We'll say x negative 4 over 3. We can agree that this is the derivative of this.
Yes.
We agree?
Yes.
Yes, King? Yes, King?
Yeah. I'm about to kick you out my house, bro. I'm about to go to bed, bro.
Yes, King?
Sure.
Louder.
No.
Louder.
No. Yes, King.
Thank you. So we agree that this is one part. So we'll say this is. I mean, we don't even have to name this. This is just the alpha. This is the beta.
What the fuck?
You know. It's just. I'm just naming it.
You're just fucking bullshitting
I'm
me.
just giving it a name. This is literally how you do it. I'm just giving it a name because I give every derivative a name. So I'll say this is the beta part of the derivative.
Okay.
We then write in 5, which is the original part. So here's the tricky thing about the power
Are we
rule.
about to product rule this shit?
This is the power rule. Please, don't make me yell. So here's the tricky thing. You have to see. Oh shit. You have to see that this now has to multiply into this. This is the first part of the product rule. Okay?
Okay.
So, when we do this, we then say negative 5 over 3 x the negative 4 over 3. Because look. What do you see? What do you see there? What did I do there? Why is it negative 5 over 3 now?
Because you multiplied it.
Congratulations. You understand. Alright, so now what do we want to do with this negative 4 over 3?
Do we want to make it positive?
Yes, but how do we do that?
You have to bring it up the...
Bring it up!
Bring it up the fraction!
Wrong. You never bring something up if it's a negative up there. What do you do with it?
Oh, you bring it below then?
Yes, you make it the denominator. So now we rewrite it as negative 5 over 3 x 4 over 3. Stop typing! Anyways, this is now in the denominator. What do we see here? Let's go back to chat. Let's go ask Gemini. Let's ask Gemini. What do we see? Oh. What do we see? What do we see?
It looks to me like everything's fine on what this answer is, bruh.
Alright. Then put in your answer. Why is it this?
You did
Oh, but
not...
don't cheat. Well, we're not going to cheat, though. We're not going to cheat.
You did not teach me how to solve this.
I did! I went through the entire thing!
She was ass.
You should kill yourself. Don't write anything. Undo.
Why am I not allowed to tell
Hey,
Fern?
how about you do the... How about
Let
you do
me
your
tell
copy?
Fern on the halls. Who's this, bro? Alright. Hell teacher, bro.
No one's writing that in chat. Go ahead and write your thing. If you don't do it, I'm gonna jump on your bed.
Okay. God, this was so ass. W Fern of the halls, bro. What are you looking at? Where the hell was the answer on here? Five over 3x 4 3.
Can I help you?
You're
fucking problem.
definitely watching the stream right now.
Please speed, I need this. 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 Please speed, I need this.
Turn that shit off, bro. Turn that shit off, bro. Yo, you're torturing this dude, bro.
Ah, turn them lights back on.
Yeah, keep this one off, bro.
Oh, I needed to get the clip. My bad.
What clip?
I clipped you.
When?
You got 4 viewers and you're barely doing your math. How about you lock in?
Who's watching this shit?
Everyone's watching this. You're blowing up. You are the next Einstein.
Hey, chat. Hey, Front of the Halls wants me to slap you because you're making him mad, bro.
You can die. It don't matter. N
Yo, further the halls. I'll make you proud, bro. Yo! Oh, shit. I'm slapping him. I'm slapping him. I'm slapping him. Yo. Yo.
Don't piss me off.
Yo, I actually gotta get this homework done, bro. Oh my god. What am I doing here? Let me try this one.
All right, Nicholas. Let's see.
I'm good. I think I can handle this one, coach.
You can handle this one?
I can handle
Let's
this one,
see it.
coach.
I got the answer.
Got the answer?
It's not that hard of a problem.
How?
Derivative of the first plus the first times derivative of the second. Power rule.
Isn't it low D high minus high D low?
Power rule.
Oh, this is what a power rule.
What is the square root of anything?
Oh, don't touch my screen.
What is the square root of anything?
Square root of anything?
If you have the square root of anything, what is it? What is the exponent to? If you have the
1/2.
cube root, yes, that's the square root. Cube root was 1/3.
Yeah.
So the square root is going to be w 1 to the power of 1/2, 1/2.
Okay.
So then you take the inverse of that. Write this down. 1/2. Yes. What is the inverse? Nope.
2.
Let's write out the full problem. Let's write out the full problem. Come on, you got this. I believe in you. I believe in you. Write out the full problem.
Okay.
All right, you wrote it? You wrote it?
Yes.
All right. So before we even take any derivatives, what do we do right here? We see that there's a square root in the denominator. That there's a denominator in the first place. What do? We take the inverse and get the denominator up here
So you want the W
on top.
on top?
Just like where you like to be when you're getting pounded.
Yo!
But how do we do that? How do we get the W on top?
You gotta make it inverse and make it minus
What
1/2.
is the inverse of the square root of W?
Minus 1/2.
Is it?
I think so. What the hell? I was clipping anything. 60-second
Darn.
clip?
Darn. I thought I could get it where I grabbed you. Put you on the table.
Sorry, bro.
Anyways, get back to work. So, you have this now. What do you do? Oop. What do you do?
We brought it
Because
up.
this is not the same. These are two entirely different problems. And right now you're saying it's plus 8 times w to the negative 1/2. What are you supposed to do?
Derive it?
No! You're not supposed to derive it. Alright, so let me teach you something very important about mathematics. You ready? Right here is its own separate equation. You always need parentheses. If you show a toddler, if you do, say, 4 over x, if you do that, and then you take the inverse of that, you're going to have 4x to the negative 1. While that's technically correct, if you want to take the derivative of it, or some polynomial, I made a terrible example choosing 4x, hold on, plus y. We then take the derivative, or we take the inverse of this, we go 4 plus y, x to negative 1. This isn't the same at all. Because right now how you're writing this is saying 4 plus y times x to the negative 1. What it should be is 4 plus y times x to the negative 1. The parentheses mean that everything that's in here is going to be distributed both to the y and to the 4. Do you understand?
Yes.
So what must you do now?
Do you want me to distribute this?
No, I don't want you to distribute it. I want you to write it correctly because I believe in you. I know you can do this.
I'm tired. I think I'm gonna go to bed.
I'm tired, coach. That's what quitters say. I need you to be great. There is no room for error. What's wrong with you, huh? Is the seat too low? Is that your fucking issue? Is the seat height too fucking low?
What?
Is the seat too fucking low? Is that your issue? Are you gonna be able to do math correctly now?
I need a nap.
Fuck you, I don't care. Sleep isn't your issue. Who's gonna carry the boats? Who's gonna get Ziggy out of the fire? Not you. Not you. Because you're too dumb. You won't understand. It's fine. Quitter. This time, Legendary doesn't laugh last.
What?
Last.
No one never laughs, bro.
No one laughs last.
That's not the saying, bro.
Is that not the same?
Legendary laughs last, bro.
What I heard is Legendary quits first.
What?
Legendary skips legs. Legendary doesn't work out. Legendary's a fat chud. Legendary's butthole hurts after playing soccer.
What?
So
I don't know.
Let's get right back on it.
Burn of the Halls doesn't like what you're saying,
Stop reading
bro.
chat. Stop reading chat. Stop reading chat.
That's part of my job, bro.
I don't care. Your job is to not fail because you're never gonna make it out of the hood if you can't do basic math.
You're a L teacher.
Do you think Pokimane can do a derivative? Yes, she can.
No, she can't.
Yes, she can.
You know that's a lie.
Pokimane can't take derivatives. How do you think she got all of them racks?
Yeah, bro. I bet she derived her way to the top, bro.
Yes, she did. Because guess what the derivative is? The derivative is the utmost point. It's the average. Is the increase of whatever the fuck it is. I forgot. The instantaneous rate of change. So guess what? When Pokimane was down here... Here, can we mute this real quick?
What?
Right, we're back, guys. We're back. So anyways, let's take the derivative. Come on.
Oh, you just want me to drive this?
No, I don't want you to drive it.
What?
Yes, I want you to take derivative of the entire thing. But write this out again. As you have it. It's not correct.
No.
Come on.
Are you clipping yourself
No,
right now?
I would never. Come on, hurry up. What are you doing?
I'm doing the way I know how to do it, bruh.
Someone's up there.
It's Gabby. Oh, my dad might be home.
Can I help you?
What the hell did you do to my head, bro?
Nothing. Okay. Hurry up. You have learned much. Congratulations, my disciple. You have graduated Streamer University. Many prayers and thoughts go out to you and your family. Congratulations.
What does... Where is the plot in this? Where are you going?
Yeah, I guess. Sure.
Yeah, we'll be taking an intermission, bro.